This video is about thermochemical calculations using Hess law. Before you apply Hess law to solve the thermochemical problems, you should understand thermochemical equations. First, about conversion of energy diagrams into thermochemical equations. For example, this one, we have this type of energy diagram. We have A, B, and C, and this. So it's energy and it's reaction pathways. This diagram can be converted into thermochemical equations. We have this. Look at this. The edge of each arrows. Yeah. A, B, A and B started from B and the end as A. So we can say B turns into A. If we have delta H1 here, delta H2 and delta H3, so we have delta H1 here. And B turns to C, we have delta H2, and C turns to A, we have delta H3. Or another type of energy diagram, maybe like this, so that we have A, B, C, D with delta H1, delta H2, delta H3, delta H4. So we can convert this diagram analog with the previous diagram. Look at the edges of the arrows. Yeah, A turns into D, delta H4, D turns into C, delta H3, C turns into B, delta H2, and A turns into B, delta delta H1. Yeah, for example, this. So we have two types of energy diagram, and you can convert the diagram into thermochemical equations. And the second thing you should understand about before you do the thermochemical problems, you should understand basic concepts. First, you must have the thermochemical equation with the unknown delta H. Many thermochemical problems don't show you the equation with the unknown delta H, but they give you in statements just like this. We have this, the sample. What is the enthalpy change of formation of CS2? There's no equation here. So we must convert this statement into thermochemical equation. Enthalpy change of formation. So we have this one, right? It's the unknown. Formation of CS2. So CS2 is the product. from C solid plus S gas. Index number of S in right side is 2. We put coefficient for S in left side as 2. So here now we have the thermochemical equation to solve the problem. Another example is, what is the enthalpy change required to pulverize 1 gram of water? Enthalpy change required. It means this. I'm sorry. Right? Pulverize water. So we have H2O liquid turns to H2O gas. So now we have the equation to solve the problem, right? And the second basic concept is when a thermochemical equation is reversed, this I'll show you. This one. Say that you have this A turns to 2B with delta H minus 10 kilojoule. Said so. When a thermochemical equation is reversed, the sign of delta H is also reversed from negative to positive or vice versa. So when you want to reverse this into 2B turns to A, the value of delta H will be plus 10 kilojoule. Yeah. Hope you get this. And the third basic concept is when a reaction is multiplied by a certain number, the value of delta H is also multiplied by that number. Yeah. For example, this we have A turns into 2B with delta H minus 10 kilojoule. We want to change this into 1. So multiply by a half. When you multiply this equation by a certain number, you must multiply it. You must multiply delta H also with this number. So we have a half. A turns into B with delta H is minus 5 kilojoule. Hope you understand this. So now we are going to solve a problem of thermochemical equation using Hess law. For example, we have this. Yeah? We have two thermochemical equations here, and one thermochemical equation with the unknown delta H. So we must have the equation because it's not the complete equation, right? So we have this. For FeO plus 50 kilojoule, convert this minus 18 kilojoule, convert formation. So formation Fe2O3 from Fe plus O2. We have 2 Fe and 3 oxygen atom. Yeah. So we have two. We have two thermochemical equations here, but we need to convert this into thermochemical equations. FeO with the unknown delta H, and the equation is Fe iron plus O2 1, so put coefficient a half, right? Now we can do this problem using Hess law. Our focus now is this equation. It's the equation, the thermochemical equation with the unknown enthalpy change. Yeah, this is our focus. So we must modify these two equations. So the final equation will be this, our focus. How? Look at this. Look at the substances. Fe, O2, and FeO. Please recognize which substances appear only once in two equations here. Fe appears in the second equation only. O2 appears in the two equations, so we don't need to make this substance as our focus. FeO appears in only appears in only one equation, right? I gave a sign here so you can recognize the substances. You modify these two equations, so Fe will be in the left side and coefficient number of Fe is 1. FeO must be in right side with coefficient number is 1 based on this focus. We change this. Fe from left side, so we have Fe plus O3 minus, okay, but our focus says only 1, right? So multiply by a half. Then we have Fe plus minus 14, right? So we don't need to pay attention for this equation. And FeO comes from the first equation, but it's in left side. We must modify it. We must reverse this equation, right? 2FeO3 turns into 4FeO plus O2. Remember this one, minus 650 kilojoule. Because our focus shows only 1 as the covalent number of FeO, but we have 4 here, so multiply by a quarter, right? do this. So we don't need this equation, right? Now we have two equations. Fe blah 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 and a half FeO3 blah blah blah. We have two equations. We can sum this. The sum of these two equations must be our focus, the final equation. You can cancel out this one, right? You can cancel out this, and the remainder is a half. Sum, please. Fe plus FeO. So you have now okay. Hope you understand this problem. Then the second problem is we have this one. We have three thermochemical equations here, and the problem is, what is the enthalpy change of this reaction? So now we have we already have the thermochemical equation with unknown delta H, right? Our focus is here now, and choose recognize substances that appear only once in these three equations. NO appears in only, say that I have the numbers. NO appears in the equation number 1, but not in the other equations. So I put a small dot. O2 oxygen atom, oxygen molecules appear in 2, so it's not our focus. N2O4 appears in equation number 3 only, so it's also our focus. We have 2NO comes from this, but it's in right side. Yeah, so we have NO turns into N2NO2 with delta H plus minus 10, right? We have 2 here, multiply by 2. Right? 2NO turns into N2NO2, and delta H is 180, right? We don't need this equation. The second one, N2O4 comes from equation number 3. They are in the same side, right? 2NO2 turns into N2O4 minus 58 kilojoule per mole. Okay? because they have the same coefficient, so we don't need to multiply this by certain number, right? But if you see here, if you sum these two equations, you will see N2 and also NO2 in the final equations. So we must eliminate these substances using this one, right? These equations. N2 is in right side, so will be cancelled out by the one in left side. N2 here is the coefficient number of N2 here is 1, sorry, it's a half. So multiply by 2. So now you have and you don't need this equation. So you can sum them now. Yes. We now have 3 equations and sum these 3 equations and also sum delta H. You can cancel out N2, O2 here, right? Remember our focus is here. Then 2 and O2. Now sum them. 2NO plus O2 turns into N2O4. You have now minus 162 kilojoule per mole. Yeah? Hope you get this explanation. Thank you for watching.